Okay, we're going to be going over conditional statements today, but before we do that, we're going to go over some midpoint practice. So let's go ahead and start with T is a midpoint of segment SR. So we want to draw segment SR and then have T as my midpoint. Now, because it is a midpoint, we know that ST and TR are congruent, which means that they're equal. The segments are equal. So ST is 2x minus 1, and SR, which is this whole segment, is 3x plus 2. So we know that ST and TR are congruent. So then I can say that TR is also 2x minus 1. So when we set up our equation, we want to use the segment addition postulate, and we can say that ST plus TR is equal to SR. Now when we substitute, we get 2x minus 1. That's your ST. Your TR is the same, 2x minus 1. And then my SR is 3x plus 2. So then we're going to combine like terms. We're going to solve for x because that's the first thing we need to solve for. And then we need to find ST, TR, and SR. So we combine like terms. We get 4x minus 2. And then we use our algebra skills so we can solve for x. 1x minus 2 equals 2. Add 2 to both sides, and x is equal to 4. So now that we know our x value, we can substitute under ST. 2x minus 1, x is equal to 4. We get 8 minus 1, which is 7. So we know that ST is equal to 7. I'm going to label it on here as well. So if ST is 7, then so is TR. And SR is 2 of those, so we get 14. Your midpoint. Now we're going to look at conditional statements. Last week we saw that conditional statements are statements that can be either true or false, and they always start with a hypothesis and end with a conclusion. So we start with an if, and then it's our hypothesis, and it always ends with a then, followed by a conclusion. So in this example, we have if, and my hypothesis is AB, segment AB is equal to the length of segment CD, then, and then my conclusion follows, AB is congruent to segment CD. We have a hypothesis and a conclusion. All right, so for the first one, we want to identify the hypothesis and the conclusion, which is the hypothesis and which is the conclusion for this conditional statement. Well, we start with if and then. So we want to put a box around those because the statement that follows the if is your hypothesis. And the statement that follows the then will be your conclusion. So go ahead and try the next one. Okay, this is your hypothesis because it comes after if, and then this is your conclusion because it comes after the then. Okay, now we're going to be writing a conditional statement. Can you write dolphins are mammals as a conditional statement? So we want to start with if, and then we want to end with then. So if we look at these two statements, which ones would make more sense with the statement that you made? The dolphins are mammals. Would it be if a mammal is a dolphin, or if it is a mammal, then an animal is a dolphin? Or would our hypothesis be if an animal is a dolphin, and our conclusion would be then it is a mammal? And that's actually what it is. We have if an animal is a dolphin, and it is a mammal is more of a conclusion. So that's going to be our conclusion. It is a mammal. So if an animal is a dolphin, then it is a mammal. Okay, so now that we have written our conditional statement, now we're going to write the converse, inverse, and its contrapositive. So go ahead and write down this statement. If 3 points lie on the same line, then they are collinear. So let's identify the if and the then, because the if lets us know that this is my hypothesis, and the statement after then will be my conclusion. So when we do the converse, the inverse, or the contrapositive, they all have to come from our conditional statement, which is our original statement. So for our conditional statement, our statement will read, if hypothesis, then conclusion. So if my hypothesis, then my conclusion. Now when we write the converse, converse is when we basically switch. I like to call it the switch. You switch the hypothesis with the conclusion and vice versa. Conclusion. So again, my conditional statement is my original. So we're going to switch the hypothesis with the conclusion of the original or of the conditional statement. So in this case, we will say if the conclusion, then the hypothesis. So we're just switching its place. So let's practice on this one. Fine. So now the next one is our inverse. And if you recall, inverse is an opposite, and the opposite of being something is not being something. So for the inverse, I like to call it the not. And it just basically puts the not in the hypothesis and the conclusion. And again, we want to go from the original statement, which is my conditional statement. So we're going to start with if not the hypothesis. So if not hypothesis, then not conclusion. All that's switching or changing is that now it's the not, the inverse. And sometimes your hypothesis stays the same. And my hypothesis and my conclusion stay the same. All right, so now with contrapositive is basically combining both the inverse and the converse. So the contrapositive is the inverse and converse at the same time. So we're not only switching them, but we're also putting the not. So from my conditional statement or my original statement, we start with if not the conclusion, then not the hypothesis. So let's use the same statement so we can write our contrapositive. So, all right, so now we're going to go into biconditional. And for our biconditional statements, remember the word bi means two. So we're talking about two statements. And we're going to use this example. Biconditional statements are basically where your statement or your conditional statement is true, because remember, a conditional statement could be either true or false. But in order for it to be a biconditional statement, the conditional statement must be true, and when we write the converse of the statement, it must also be true. So both have to be true in order for us to say that it's a biconditional statement. And if it is a biconditional statement, we can drop the if and then we would put if and only if in between the two statements. For example, if we have a conditional statement that says if two segments are equal, so I'm going to say like AB is equal to CD, then they are congruent. Which means AB, segment AB is congruent to segment CD. So if this is true, then we're halfway to determine if it is a biconditional statement. And if you recall, if a segment, or I'm sorry, if two segments are equal, if their lengths are equal, then we can say that the segments are congruent. So this first statement is true. So now let's do the converse. I'm going to label this my conditional statement. And then let's label this my converse. So if, and now we're going to do its opposite. So let's highlight my hypothesis. And this is my conclusion. So now I'm going to switch them because we're looking at the converse. So this is my original. And this is the switch. So if they are congruent, then two segments are equal. All right, so if the two segments are congruent, then that means that the lengths are equal, and that is also true. So because they're both true, then that means we do have a biconditional statement, and the way we will write it is that we'll get this hypothesis, and then we'll say if and only if the conclusion. So we will say with this example, two segments, let me write the word two because it's the beginning of a sentence, two segments are equal if and only if they are congruent. Then our new phrase in the middle, if and only if. And we can only use that statement if it is a biconditional statement.